Okay, so in 4.4, we cover the fundamental theorem of calculus. That seems kind of like a big deal. And something else, which we're going to get to tomorrow. So for right now, let's just go ahead and jump into theorem 4.5, the definite integral. Now, so far, we've been doing indefinite integrals, okay? Definite, that just means that you have a number here and here. And what does that mean? That's today's lesson, okay? If you notice on the homework before, we didn't have numbers at the top and the bottom. We're also going to be talking about area, which should kind of make you think about Riemann sums. I'm going to make a connection between what we were doing last week and Riemann sums. I think it's not going to be more work. I think it's going to help you understand Riemann sums better, and understanding Riemann sums is going to help you understand this better. So here's what this theorem states. If we have a continuous non-negative closed interval, that's just the conditions, then the area of the region bounded by the graph of f, the x-axis, and the vertical lines is given by an integral. Okay, so in this problem, this thing right here, what it means is this shaded area. Okay, that's what it means. We've already been estimating the shaded area when we did Riemann sums. You've also been doing this in other math classes. We did this at the beginning of the year in the after parties. I was having you find area like this. Okay, so before we do the calculus, I would like for you to estimate this area. We don't have a formula, so we're not finding it exactly yet. We're going to get to that. I just want you to estimate this area right here. So everybody on their own. You can use triangles, trapezoids, rectangles, semicircles, whatever you feel comfortable with.
We're supposed to do real math or just an estimate?
It's just an estimate. You can be as specific or as vague or whatever. It's up to you. Okay, anybody want to share their estimate? 8? What else? 9? 7.5? Did anybody get something between 10 and 11? Like 10 or 11 or anything in between? So the true answer comes between 10 and 11. That's why I was just curious. Okay, how do you know that? You don't yet. That's what today's lesson's for, okay? So let's talk about Riemann sums for just a minute. What shape did we use for most of the Riemann sums? We had trapezoid, but for most of them it was a rectangle. And we discovered with Riemann sums that like 4 rectangles would be okay, but what was better? 20. What's better than 20? A lot. Infinitely many. And, whoops, I just am skipping around here. There we go. If you want to have a whole bunch of rectangles, that could be time consuming. Your calculator could probably do it, but what would each rectangle probably look like? It would be small in which way? It'd be short?
No, it would be not wide.
Yeah, it would kind of almost look like a vertical line. So I'm going to draw a very skinny rectangle right here. And let's come up with the base and height of this rectangle, not in numbers, but just in general. How did we find the height of those rectangles? We looked at the y values. So at this particular point, the y value is the height. What's another phrase we use for y? It starts with f and it ends in of x. F of x. Okay? Yeah, that's an old joke. All right, the base. How do you calculate the base of the rectangle? What do you do?
Multiply it by the time.
That's what we do with the base. How do we find the base? We counted it.
Look at your table.
So if this was at 1 and this was at 1.2, what would you do with those numbers? You would subtract. Okay, and I'm going to call this dx. So let's recall, what does d mean? Not, and I don't mean derivative. Do y'all remember which Greek letter d stood for? Delta. Okay, and what does the Greek letter delta mean in math class? Change. So this is like x2 minus x1. I'm using these things for a specific reason, because it's right up over here, if you kind of see where I'm going with this. So if I wanted to find the area of just one rectangle, I would do f of x times dx. That would be the area of just any one given rectangle. And how many rectangles did we say we wanted? A whole bunch. So this symbol right here means I'm going to add all of them up. Okay? Add them up. Not forever, but from an x value, in this case -2, to another x value 2. So the places where you start and stop, these are these numbers right here. We're going to start at x equals -2, and we're going to stop at x equals 2. And that is an integral. That's going to represent the true area under the curve exactly. Okay, and we're going to use the concept of antiderivative to do this by hand, and we're also going to use our calculator to do this. Okay, so I'm going to write this down one more time, kind of now that I've written this. This symbol right here just means we're going to add everything up, like a Riemann sum. The f of x, that is the height of the rectangle, and the d of x, that's the base of a given rectangle. Okay, what you need to know moving forward is how to set up something based off of a graph or a description. So whenever you start seeing like area of this region, we know we're going to have to do an integral. Okay, the next thing we need to do is from what to what. In this problem, it's going to be -2 to 2. In other problems, it will be other numbers. Okay, and we'll talk about how do you find those numbers. Okay, our f of x in this problem is 4 minus x squared. And then don't forget dx. We know doing antiderivatives, we're not going to do a lot with the dx, but it's part of the notation and it needs to be there. Okay, so we've estimated the answer. Okay, now let's find the answer exactly using technology. And then we're going to move forward in finding the answer without the technology. So I'm going to clear all this out. And I'm going to clear my variables just in case I entered something in last week and forgot. So the way you're going to type this in the calculator is you're going to do F3, option 2, integrate. And it puts the integration symbol. Then you're going to type in your function, 4 minus x squared. Do y'all remember what comes next with this kind of stuff? Comma x. Yeah, so remember, comma x. And we last week closed the parentheses and it just found the actual antiderivative expression. We're trying to take it further here. So we're going to do comma -2, comma 2. Notice the order that I went with that. I started with the left bound and then I went to the right bound. The lower, then the upper. Okay, now when you press enter, it's going to put it in pretty print for you. Pretty print just means it looks more like how it is when it's typed. So if you're getting these numbers mixed up, you should be able to figure it out, like at this step. That's a common thing. So that's our answer, 32/3. If you wanted a decimal, you just go diamond enter. So that's why I was saying, if you got between 10 and 11, you did a really good job. And it was just estimating, so there really wasn't any bad answers. Okay, so that's how we find the exact answer with technology. I've already shown you that, right? That's not really new. Okay, before we go through and do this by hand, like without the calculator, I want to talk about a couple of properties. Okay, first of all, look at this right here. See how these numbers are the same? And we can type this in the calculator. Like if I make both of these just 2, like the exact same number, like no -2, it's just 2 to 2, I get 0. Why do you think that is? Yeah, there's no change. So what's dx? 0. And there's no area. It really would just look like a true vertical line. Okay, the next property says that if you switch the upper and the lower, it should change your answer by multiplying it by a negative. So let's see how that holds up here. Let's do 2 comma negative 2. And we get a negative answer. Now, as we move forward out of non-negatives, a negative answer could be the right answer. The answer is not always positive, okay? In this problem, the answer should be positive because the graph is above the x-axis. But that's how this switches. It negates it. The number's the same. It just puts a negative in there. All right, and so that's kind of what this last one says. We should get a positive answer if the area is above the x-axis. What is that implying about area below the x-axis? That those integrals should be negative. Area itself cannot be negative, but an integral can be. All right, so here's the big thing for the day. All right, highlight this, do whatever you want. The fundamental theorem of calculus. The fundamental, what does that mean? Important, basic, core. The most important theorem of all of calculus. That's what we're about to learn. That does not mean it's difficult. It just means it's really important, and it's something we're going to do a lot from now on. So, if we have a continuous function on a closed interval, and we're able to take the antiderivative, okay? We take the antiderivative, we plug in the top number, plug in the bottom number. So that doesn't really make a lot of sense, right? I just kind of said it really fast. So let's do the example. Okay, let's antiderive. This is really, if you break this down into two things, we are going to antiderive, and then we're going to plug in numbers. So what is the antiderivative for? 4x. Okay, minus. What's the antiderivative of x squared? 1/3 x cubed. Okay, notice that I am no longer writing the integral symbol because I integrated. I found the antiderivative. This is how you still represent the numbers. Oh, what am I forgetting? Plus c. If I could, I would like write this plus c in kind of like a lighter shade of blue, but I can't, and I'm going to explain why here in a minute. You see if you can catch on quicker than I'm going to tell you. So write this bar and then write the numbers. Put it at the end. That shows that I did antiderive, but I still need to plug in the numbers. So now we need to plug in, and I'm not going to write numbers. I'm going to say bounds. The lower and upper bound. You're going to start with the upper bound. Because see how this says to do that? All right, so 4 times 2 minus 1/3 2 cubed plus c. So that's what I get when I plug 2 in for x, the upper bound in for x. Then I'm going to do minus f of a. So I'm going to do minus. Now I'm about to do several things. So let's put a parenthesis. This shows that I'm going to subtract everything else I'm about to write. We're going to have to distribute or simplify or something. Okay, now I'm going to plug in negative 2. 4 times negative 2 minus 1/3 negative 2 cubed plus c. All right. You don't have to simplify when you have a free response question. Okay? When do you have to simplify? When it's multiple choice. Okay? And these can be multiple choice a lot. So we need to know how to simplify. So I want you to go ahead and simplify this one, knowing that it was okay to have this as your final answer. But I want you to go ahead and simplify. And you know the answer should be 32/3. We already figured that out. That's our multiple choice answer. Here's our free response. And you should be able to do this without a calculator. You're not going to have to do it a lot, but you got to know how to do it. Okay. What happened to the C's? They cancel each other out. In fact, I could have figured that out up here. So did I really need the plus C here? No. We need it when we don't have bounds, but when we do have bounds, we don't need it. Don't freak out about when to write it and when not to write it, okay? Just let it make sense. The C's are going to cancel out here. Okay, so free response, don't have to simplify. Multiple choice, you need to know how to simplify correctly. Okay, let's turn the page, and we're actually going to skip 3, and we're going to look at number 4. Okay, so here's a way the problem could be asked. Find the area of the region bounded by this parabola, the x-axis, and the vertical lines x equals 0 and x equals 2. So what they're talking about is this shape right here. Again, I don't have a formula. I'm not on my game today with drawing. I don't really have a formula to do this. Okay, I'm trying to find this area. Can you estimate that area just by counting the blocks? What would you say that is about? Well, look on your own paper. A little over 3, 3.5. Sounds good. Okay, so how would we do this in our calculator? We already know. You can check it if you want. Let's practice doing this by hand, though, on this one. So we need to write the integration symbol. What are my lower and upper bounds? And remember, these are x values. Think left to right. 0 and 2. Okay, 0 to 2. That's how you figure it out if it's not given. Okay, then we have our function. And then we have dx, and we anti-derive. Okay, so anti-derive this with me. 2 over something. Write your x. Add 1 to the power. You get 3. So that's the number you put down in the bottom. So what should the next one be? 3/2 x squared, and then 2x. We don't need the plus c. I'm not going to write it. Okay, put the bar, put your numbers. So if you're stopping, put the plus c. If you put the plus c, your next step should be the c's canceling out. So it's not going to hurt you to put it in this case if you didn't need it. I don't need it though. They're always going to cancel out with these numbers. All right, so then let's plug in 2. And sometimes you get lucky with numbers like 0 because you can kind of already tell what's going to happen when you plug 0 in. What's going to happen? These are all going to cancel out. So there's not always a ton of number crunching. And if you can see that, you could have just written a single 0. Oh, thank you. Okay, so this is our free response, unsimplified, ugly answer. Okay, I'm going to go ahead and give you the simplified one is 10/3. That's a little over 3. So that was right in line with our estimate. Okay, you can, if you want the practice, plug it in your calculator, see if you get the same thing. Okay? So the fundamental theorem of calculus isn't that hard if you already know how to anti-derive. All right, so far we've only been dealing with non-negative graphs that are completely above the x-axis. So what do you think we're going to do next? Work with graphs that aren't. Okay, so off to the side, let's graph this parabola. And it looks like I need to graph it from 0 to 5. So I'm going to mark off 5 tick marks. And how could we graph this parabola? besides completing the square, besides vertex, just how could you graph something? When x equals 0, how do I figure out the y value? Plug 0 in. 0 is pretty easy to plug in. You just get 8. And this is just a sketch. The graph is not my answer. It's just there to kind of help me with the problem. Okay? I'm going to give you the rest of these just due to time. When you plug in 1, you get 3. You plug in 2, you get 0. You plug in 3, you get negative something. And it looks like this. Okay, you could have made a T-chart and done this yourself, but I'd rather get on with the good stuff. Okay, so that's my ugly parabola. And if you notice, it's not non-negative. There's pieces of the parabola that are above the x-axis, and then there's also pieces that are below. So look what we have right here. And I'm going to really work this problem to death here, because this is where we're kind of stick for the rest of the lesson. How would I write just that integral? What would I do? What are the left to right? X equals 0 to 2. And I'm not going to, it's this function, I'm just going to write it as f of x. I'm not going to write the whole thing out. Okay, I would like all the girls in the room to evaluate this integral, either by hand or in your calculator. Okay, guys, this is what you're going to do. You're going to do this integral. Now, this is below the x-axis, so we expect something different to happen. What would be the bounds here? 2 to 4. So 2 to 4. So you're basically doing the same problem. Again, you can do it by hand if you want, or you can do it with your calculator. And then I will do the last one, since I've already done this a few times today and already know the answer. And that'll be this one. So I want to know, like, your answer should just be a number. It's going to be a fraction. Yeah, all of them are fractions. Do I have 2 girls with the same answer? I have 1 girl with the answer. What'd you get? What? You do the top first. I'm going to write it as that fraction, 20/3. Only because it'll make it kind of a little bit easier. 20/3. Which is correct. It's the same as 6.6 repeating. Alright. Any guys get the middle one? -4/3. So, first thing I want everybody to notice is when the area was below the x-axis, that interval was negative. I want to make sure everybody's got this. The area is +4/3. The integral is -4/3. Area is always positive. An interval can be positive or negative. So if I just wanted to add up all 3 areas, there might be a reason why I need to do that. Okay? There is going to be eventually. And if I just wanted to add up the areas, I would get 28/3. Okay? But if I want to do this, which is all 3 together, I have got to do, all 3 of these. Now, this is kind of nice because the -4/3 and the 4/3 cancel, so we just get a 20/3. Okay, we can easily check this by doing the integral 0 to 5. We would get 20/3. Your calculator knows to do this. Your calculator is very smart. When you do this by hand, the fundamental theorem of calculus knows to do this. Okay, the reason I want you to know, let's fill in these blanks and then let's look on the next page. So graphically, what an integral represents is the area above the x-axis minus area below. Okay, there are certain types of problems where you really need to understand this. So the next one is, and these end up being probably the easiest problems, but you have to know what you have to understand when to use a negative. So what this means right here, the area of the three shaded parts are 10. So this shaded part's 10, this tiny shaded part's 1, and then this shaded part over here is 5. All the areas are positive. The integrals could be positive or negative. It depends on where they're at. So when we're looking at A, -3 to 0, I start at -3, I stop at 0. So I have a 10 that's above the x-axis. So that integral is positive 10. What am I going to do with this 1 though? I'm going to subtract it. So that's going to make 9. That integral is 9. The area is positive. The integral could be positive or negative. All right, look at B. B is the exact same bounds, but they're switched. So how is that going to change this answer? This was one of the properties. It's going to be negative. Think about it this way. Instead of going left to right, we go backwards, right to left, and that causes a negative to be there in my answer. All right, what about all the way left to right? -3 to 2. We'd have a 10. We already know we have a -1. What would we do with the 5? Subtract it, and we'd get 4. Okay, what do you... Okay, so, and you